Dear Boundedness International Study Channel followers, how are you? Welcome to Boundedness International Study Channel Grade 12 Mathematics lesson in Ethiopian curriculum. My name is Yamata. If you're interested in my presentation, you can subscribe, comment, like, and also share. Now, let us start our today's presentation. The upper bound and the lower bound of the given sequences. Now, to see this clearly, we can consider first set any sets. The set, let's say let's say S, which equals to say simply 2 or minus 2 up to say 5. We can consider the set this, or we can write this set in the real number lines last, which is the set means which we can say we have number 5 here, and also what's number negative 2 is here. Now the set is containing every real numbers between -2 and 5, and also including themselves. Therefore, as we can consider all the numbers which is above the number 5, and there are also another set of numbers which is below the number 2. Therefore, we can consider from this part, or this part is now known as the upper bound. For what? The set. For the set S given here -2 up to 5. So the numbers which is greater than or equals to up to 5, or simply above the set, is known as the upper bound, or and again the set which is less than the small number which is known as the lower bound of the set, which means, in other words here, which is for the given set S, which is from -2 up to 5, we can say the upper bound from this part, which is upper bound, is the upper bound. Bound is exactly equals to from 5 up to positive infinity, and also the lower bound is also equals to from -2 up to negative infinity. ስለዚህ ምንድነው እዚህ ጋር የምናየው ነገር አንድ ስብስብ ወይም አንድ ሴት ቢሰጠን ይሄ ከሴቱ የሚበልጡ ማንኛውም የነባራዊ ቁጥሮች ወይም ሴት ኦፍ ሪል ነምበርስ በሙሉ ምን ተብለው ይጠራሉ? አፐር ባውንድ ብለን እንጠራቸዋለን ማለት ነው። ነገር ግን ከዛ ስብስብ የሚያንሱ ማናቸውም ሴት ኦፍ ነምበርስ በሙሉ ሎወር ባውንድ ብለን እንጠራቸዋለን ማለት ነው። If we consider when we bring this in our concept, which is the sequences, we can consider the sequence. Consider the sequence. Let's say here an is equals to say 1 over n. If we consider this sequence, so few terms of the sequences are, we can say if n is 1, we can say 1. If n is 2, 1 over 2. If n is 3, 1 over 3. 1 over 4, 1 over 5, and extra in such a way. So you can observe this. This is the sequence given by 1 over n. So all these numbers are simply it's decreasing. Since n cannot be negative, the value it decreases to what? 0. Therefore, all these values are less than or equals to what? 0 and greater than also 1. Meaning that we can say the value which is 1 over n is 1 over n. 0 is less than, which is say 1 over n, and less or equal to say 1. Meaning is that the value of the sequence is in between 1 and 0. Therefore, we can say the number which is greater than or equals to 1 is another set of numbers. That set of numbers is known as the upper bound of the given sequence 1 over n. And also the number, any set of numbers which is less than, which is the value of 0 or less or equal to the value of 0 is known as the lower bound of the sequence an. Which means that here this implies that the upper bound, the upper bound of the sequence, the upper bound of the sequence 1 over n is simply the number from 1 up to positive infinity, and also the lower bound of the given sequence 1 over n is simply from 0 up to negative infinity እናገኛለን ማለት ነው። ስለዚህ ምንድነው አንድ ስብስብ ቢሰጠን የሴት ኦፍ ሪል ነምበርስ ሜምበር ሆኖ ከዛ ስብስብ የሚበልጡ ማንኛውም ስብስብ አፐር ባውንድ ሲባል ከዛ ስብስብ ከተሰጠው ስብስብ የሚያንስ ማንኛውም ስብስብ ምን ተብሎ ይጠራል? ሎወር ባውንድ ተብሎ ይጠራል ማለት ነው። Now when we come to the formal definition of the upper and lower bounds of this sequence, the formal definition as a definition here. Here let's an be sequence of numbers, a sequence of numbers, and also m and m is an element of set of free numbers. M is a small letter. Now here we can say the first definition here says that m is said to be the upper bound, the upper bound of a sequence an if we can say m is we can say and if m is greater or equals to ai for every ai an elements of in the sequence a. Look, we have a sequence. For this sequence, we have set of numbers, patterns of numbers. So, if this sequence have an upper bound, if the sequence have an upper bound, then m is said to be an upper bound. So m is greater or equals to ai for every I. Each symbol, we know that this means for every I, for all ai, and elements of an. We can say m is greater than or equals to ai. We can say this number m is known as the upper bound of the sequence n. Don't forget that this is also a set of numbers. So another second definition says that m is said to be the lower bound, the lower bound of the sequence an, if we can say m is less or equals to, we can say here m is less or equals to ai. This works for every ai and elements of the sequence here to say an. Then m is said to be lower bound, the lower bound of the sequence. So m should be less or equals to for every ai in a sense for a1, a2, a3, a4 up to say an. For all ai in the sequence an. So m should be less or equals to ai. We can say this set of number containing m is known as said to be, which is the lower bound of the sequence an. Meaning to generalize, so a sequence an is said to be bounded if it is bounded above, meaning that how it is an upper bound, and also bounded below, meaning it has a lower bound. So a sequence, under sequence tada bounded row ብለን የምንጠራው ከላይኛው በኩልም bounded ሲኖረው ሲሆንና ከታችኛው በኩልም bound ወይም ደግሞ upper bound እና lower bound ሲኖረው we can say the sequence AN is said to be bounded ብለን እንጠራለን ማለት። ነገር ግን ከአንደኛው ብቻ upper bound ብቻ ኖሮት lower bound ካልኖረው ወይም ደግሞ lower bound ብቻ ኖሮት upper bound ከሌለው sequence bounded ነው ማለት አንችልም። To be a sequence is bounded, it should be bounded above, meaning that have an upper bound, and should be bounded below, meaning that have a lower bound. That is a sequence AN is bounded if and only if for every there exists a number k which is positive, say that we can say the absolute value of AN should be less or equals to the value of k for every n is an element of set of natural numbers, and then we can say the sequence AN should be bounded. Get it? And the sequence is in bounded local. There exists a number k which is positive, then the absolute value of the sequence AN should be less or equal to k. So this works for every n in the set of natural number n. We can say this sequence. Meaning this implies that the absolute value of k less or equals to AN less or equal to k means we can say minus k should be less or equals to AN should be less or equal to say what? K. In this case, the sequence AN should be bounded so that the upper bound is the number from starting from k from the number which is from k up to positive infinity is known as the upper bound. The number from minus k up to say negative infinity is known as the lower bound. So that we can say the sequence AN should be bounded. Say for example here, find the upper bound and lower bound. The lower bound of each of the following sequences. The first part is the sequence n minus 1 over n plus 2. The second part is B part is let's say minus 1 the power of n over n for this case. The third part is let's say simply to the power of n, and the fourth part is d, which is simply 1 minus n. We can say. Let's see here. So the sequence, the first part is n minus 1 over n plus 2. The second part is minus 1 the power of n over n, and c which is to the power of n. And the other part is the part which is n 1 minus n. So let's set the correct. This is 1. Now let's see as a solution. Here, given the first part is A, the sequence which is an is exactly simply n minus 1, n minus 1 over n plus 1, n plus 1. Now, the first two terms of this sequence here, the first few terms of an are we can say operates from starting from 1. If n is 1, we have 0. If n is 2, which is simply 1 over 3, because n is 2, 2 minus 1 is 1, 2 plus 1 is 3, so that 1 over 3. If n is 3, we can say 3 minus 1 is 2, 2 over which is 3, 3 plus 1 is 4, this means simply 1 over 2. And also if n is 4, the value of n is 4, 4 minus 1 is 3, and here it is 4 plus 1 is 5, we can say 3 plus 3 over 5. If the value of n is 5, which is 5 minus 1 is 4, and again 5 plus 1 is 6, this 6 means also 2 over 3. So we can continue in such a way. So the first few terms of the given sequence n, which is equal to n minus 1 over n plus 1, is 0, 1 over 3, 2 over 4, 3 over 5, 4 over 6, and also continue in such a way. As you observe here, the value of the sequence is something which is increasing, but it increases to simply the value say 1, approaches to say 1. Therefore, this expression can be expressed that the value which is 0 is less or equals to an is simply 1 minus n minus 1 over n plus 1, and this is also less than the value which is 1. Therefore, this can be expressed as now this sequence is bounded above from 1 and by 1 and bounded below by 0. Therefore, here we can say the lower bound of the sequence, it is an which is minus 1 up to over n plus 1 is in the lower bound the number which is less than or equals to say 0, which the value which is simply from 0 up to minus infinity, from 0 up to minus infinity. In the same part, the upper bound of the sequence which is n minus 1 plus over n plus 1 is simply the number which is greater than or equal to 1, therefore which is the value from 1 up to positive infinity. ምንድነው ይሄ እንግዲህ እንደምታዩት ምንድነው ያደረግነው sequence, since a sequence is a function whose domain is a set of positive integers or simply natural numbers, we can operate the value of n starting from 1. So if n is 1 starting which is 0, and you can continue in such a way. So as you observe here, the sequence is increasing, እየጨመረ ነገር ግን ምንም እንኳን ቢጨምር ከአንድ አያልፍም. We'll see later on, since it is this value, the value fit a rational function f of x of the form simply x minus 1 over x plus 1, which is a rational function of the same degree for the denominator and denominator. The horizontal asymptote is simply y equals to the coefficient of this and the coefficient of this, which is simply 1. This is the maximum value of the number. The same fashion here, it increases for the sequence of the value as n also increases. Whatever this increases, it does not greater than the number which is 1. All the values which is less or equal to the number 1. Therefore, the sequence is bounded in such a case. So, if it is bounded, the upper bound is from 1 up to infinity. The lower bound is from negative infinity up to 0 ነው እናገኛለን ማለት ነው። Very interesting part ነው እዚህ እንደምታዩት B part ለማየት B part given a sequence which is an is exactly equals to simply minus 1 the power of n over n. So when we observe here some few terms, the first few terms are the first few terms are we can say here if n is 1, simply minus 1. If n is 1, minus 1 over 1 is simply minus 1. If the value of n is 2, minus 1, the power of 2 is positive 1 over 2, which is 1 over 2. If n is 3, which is minus 1 over 3. If the value of n is 4, which is 1 over 4. If the value of n is 5, which is minus 1 over 5. As you observe here, minus 1, and again 1 over 2, and again minus 1 over 3, and again, which is negative, positive, negative, positive, negative. So it's increase, decrease, increase. It oscillates. Which oscillates? This is exactly equals to either minus 1 over n or simply 1 over n. If n is odd value, and this if the value of n is say even value, meaning the value of odd starting from 1, which is say minus 1, minus 1 over 3, minus 1 over 5, minus 1 over 7. If the value of the odd values, which is minus 1, 3, 5, 7, and continue in such a case, which is say decreasing towards the value of 0. But if the value of n is even, meaning which is say 2, 4, 6, and 8, we can say n is 2, we can say 1 over 2. N is 4, we can say 1 over 4, which is 6, 1 over 6, and 8, 1 over 8. This also from the right side decreases to what the value, which is 1 of 0. Therefore here, from all these terms, the minimum number of the numbers, which is negative 1, and the maximum part is 1 over 2. Therefore, this sequence is the sequence an, which means minus 1. The power of n over n should be less or equals to 1 over 2, and this should be greater than, which is negative 1. Hence, from this we can conclude that the upper bound is the upper bound is the number which is greater than or equals to 1 over 2, which is 1 over 2 up to positive infinity, and also the lower bound is the number which is from negative 1 up to negative infinity ነው እናገኛለን ማለት ነው። እንግዲህ ሲኩዌንሱን በዚህ በምታዩበት ሰዓት እዚህ ጋር ኦድ ፓርትና ኢቭን ፓርት ስንሄድ እዚህ ኦልሞስት እየጨመረ ወደ 0 ነው አፕሮች እያደረገ ሄደው። እዚህ ጋር ደግሞ ከ1 ኦቨር ተነስቶ እየቀነሰ አሁንም ወደ 0 ነው አፕሮች ያደረገው። ስለዚህ ከዚህ በጣም እየቀነሰ ሄዷል። ሚኒንግ ከራይት በኩል ከ1 ኦቨር 2 እና ከኔጌቲቭ 1 ከዚህ ወደዚህ እየቀነሰ መጥቷል። ከዚህ ወደዚህ እየጨመረ መጥቷል ማለት ነው። So the sequence we can say bounded between minus 1 and 1 over 2, so that the upper bound is from the set of upper bounds are from 1 over 2 up to infinity, and the set of lower bound becomes say from minus infinity up to minus 1 ነው እናገኛለን ማለት ነው። When we come to the third example says that the sequence is given an equal to say to the power of n. So from this part, few terms of the sequence are if n is starting from 1, so the value if n is 1 becomes say 2. If it is n is 2 becomes say 4. The value of n is 3 to the power of 3 becomes say 8. The value of n is 4 becomes to the power of 4 is 16, which is 32, and continue in such a way. Therefore, here, as the value of n approaches to infinity, then the value of to the power of n becomes larger and larger without bound. Hence, for this sequence, the sequence which is to the power of n has no upper bound, But the sequence which is less than or equals to number 2 becomes a lower bound. But this sequence has a lower bound. A lower bound is which is from minus infinity up to 2. So you can observe here the sequence has no upper bound but has a lower bound. Therefore, we can not say that the sequence is bounded. In the previous part here, since it is an upper bound and a lower bound, we can say the sequence is bounded. We can say bounded, but this part is not bounded. Even if it has bounded below, since it is not bounded above, so the sequence is not bounded totally. When you come to the fourth example, the sequence is given that an equals to 1 minus n. Now, so given 1 minus n, we can observe that some few terms of the sequence are, which is if the starting from 1, the value, if n is 1, so the value here it is 0. Because of here 1 minus 0 becomes 1 minus 1 is 0. If the value of n is 2, the value becomes minus 1. If n is 3, becomes minus 2. If n is 4, so n becomes minus 3, and continue in such a way. As you observe here, the value of some types of sequence it decreases without bound. Meaning that as the value of n increases, as the value of n becomes larger and larger, the value of an becomes decreasing without bound, so it decreases towards negative infinity. Hence, we can conclude that the sequence an, which is 1 minus n, has no lower bound. Or we can say not bounded below, but has an upper bound, which is the upper bound is the number which is greater than or equal to the number 0. So from 0 up to positive infinity is known as the upper bound. So that in the same fashion for what the third example, the fourth example says that the sequence is bounded above even if it is not bounded below. So we conclude that the sequence is not bounded sequence. So in the mathematics, የተወሰኑ ተርሞችን ወስጄ የኤን ዋጋ ሳየው 0 ኔጌቲቭ 1 ኔጌቲቭ 2 ኔጌቲቭ 3 እያለ ይቀጥላል። እዚህ ኦፕሬት እናደርገው ከአንድ ጀምረን ለኤን እየሰጠን ማለት ነው። እና የኤን ዋጋ very large number ስናገኝ የኤን ዋጋ very small number እየሆነ እየቀነሰ ይሄዳል ማለት ነው። So as n is becomes larger and larger, so the value of n becomes smaller and smaller without bound. Due to this reason, the sequence 1 minus n has no lower bound, but it has an upper bound which is from 0 up to positive infinity ነው እናገኛለን ማለት ነው። ስለዚህ ይሄን ይመስላል ማለት ነው። እንግዲህ አሁን ያየነው ባጭሩ the upper bound set ስብስብ ቢሰጠን ለዛ ስብስብ ወይም ለዛ sequence upper bound እና lower bound እንዴት እንደሆነ ነው ለማየት የሞከርነው። so ከዚህ የሚቀጥለው ምንድነው? so the least upper bound and the greatest lower bound ምን እንደሆነ ቀጣይና ያ ማለት least upper bound from the upper bound and the greatest lower bound from the lower bound ምን ይመስላል የሚቀጥለው ቶፒካችን ይሆናል ማለት ነው።